Hi all, welcome to the second lesson on integration by parts. Just giving you a chance to practice it, use it well, and we're also going to do it in a couple different contexts so that you have practice with those review subjects as well. So here you have your formula of integration by parts. So you're looking to take an integral that is a product, break it up into u and dv, and then create your table just like you would for the product rule, and then plug it into the other side. So we are going to use parts, but we're also going to do some review of finding the area between two curves, and then for number 2, volume, since those are both things that are going to be helpful to review in calculus. So if I'm looking for the area bounded by two curves, if you want to look at the graph here, you can. We've got two curves like this. And so the first thing we're going to do is ask ourselves, all right, where do they intersect so that we can find this area here. Now the easiest place to ask where do they intersect, set them equal to each other. And our two curves here are x ln of x and 5 ln of x. It's got two intersection points if you look at the graph. The easy one to find is that if we just cancel out the ln of x terms, we then get x is equal to 5. It will also equal, when this is equal to 0, it will cancel out on both sides since they'll both equal 0. And so then our other point is at x equals 1. So these gives us the bounds from 1 to 5 of our integral. And then the upper bound here is 5 ln of x minus x ln of x to find the area between the two curves. Now, in order to turn this into a product, because remember that's the goal, we want to be able to basically go just like that, what I am going to do is I am going to write this in factored form, because again, we're looking for a product. So 1 to 5 of 5 minus x times ln of x dx. So that's going to be our product. Now, in this case, remember when we have u dv, it's usually best to put the polynomial in as u, but if you remember from yesterday's lesson, ln is a really challenging integral. It involves a lot of parts. So I am going to put that here because then I will be able to simplify. Everything is now just in terms of x without any additional types of functions. And this is often going to happen in parts, is you just got to sort of figure out which one is your v and which is your u. And sometimes you'll try one way and it just doesn't work out that well. Try again. Sometimes you'll have to do integration by parts twice. That's just fine. If dv is 5 minus x dx, then this is 5x minus 1/2 x squared. So when I plug it in, I'm going to do it down here. We have our u dv, which is right there. That's great. That's equal to u times v. So in this case, 5x minus 1/2 x squared ln of x minus our v du. Oop, forgot my dx there. That's all right. So that's the integral of 5x minus 1/2 x squared times 1 over x dx. And now here's the important thing. We are still going to deal with these bounds. I'm just omitting them for notation's sake right now. So then we have 5x minus 1/2 x squared times ln of x minus, and this is why I made the ln my u, is because now I can just cancel out with these terms here. So then that's 5 minus 1/2 x dx, and I know I've succeeded in parts because I can definitely do that integral. So I'm going to bring it all the way down here so I have space enough to do some algebra and arithmetic. So 5x minus 1/2 x squared times ln of x minus 5x minus 1/4 x squared from, and this is where I'm going to put the 1 to 5. So you'll notice when we're using parts, we don't change the bounds. It's still 1 to 5. When I plug those in, I then get 25 minus 12.5 times ln of 5 minus 25 plus, because I'm doing the two negatives, 6.25. Here, we're about to plug in 1 for ln, so that this whole first term is 0. So minus 0 plus 5 minus 0.25. We could do some algebra here, but honestly with this ln of 5, I'm not going to be able to get a fully simplified answer. If you want to, you can. Otherwise, you can use your calculator and you get 6.118. Remember, always do 3 decimal places. Hopefully this example was helpful. Now let's do a little review for cylindrical shells. So find the volume using cylindrical shells. For the volume created when you rotate the region bounded by the curves y equals e to the x equals 0, y equals pi around the x-axis. So as usual with these, I am going to start by drawing a picture. So we've got our curves. We have our bounds. We have y is equal to 0, so that would be this. We've got our y is equal to pi, which is a horizontal line, and then e to the x, just like so. Now, we're going to use shells rotated around the x-axis, so the way I would draw is then we have a dy shell around the x-axis, like so. And we have the height of that shell and the radius. So this would be the radius of the shell. This would be the height, which is equal to x, and the radius, which is equal to y. So what we're looking for then is, in terms of y, our bounds. So our lower bound, we start at 1, where e to the x crosses the y-axis, and our upper bound is y is equal to pi. So using shells, remember that this is 2 pi r for the circumference times height times dy, since that would be the very thin width of the shell. So in this case, we're going to have 2 pi r, which is y, times x dy. Now what I hope you notice is that this is the weird one out. Well, I can just rewrite that. Since I know that y is equal to e to the x, that means that x is equal to ln of y. Everything between 1 and pi is positive, so I don't need to worry about negatives, which is really great. And so then what I am actually going to integrate is 2 pi y ln of y dy. And here's where we see why we want to use parts for this, is we have our product here. I'm going to factor out the 2 pi as a constant, and then y ln of y dy. I'm going to say that u, again, is equal to the natural log. So then du is equal to 1 over y dy. dv is then equal to y dy. Oh, I don't know why it's doing that. So then v is equal to 1/2 y squared. So then following our formula for parts, we then get 2 pi, and then I'm going to say then it's u v, because we already have our v du right here. So then it's 1/2 y squared ln of y minus the integral of v du. So 1/2 y squared times 1 over y dy from 1 to pi. So then that's 2 pi times 1/2 y squared ln of y minus, and this integral, again, following similarly from before, is just the integral of 1/2 y. So that would be 1/4 y squared from 1 to pi. Plugging in for our terms, for our bounds, we get 2 pi times pi squared over 2 ln of pi minus pi squared over 4 minus 0 plus 1/4. This is definitely not going to simplify nicely because we have the natural log of pi, we have pi squareds, we have a pi on the outside, we have decimals. So again, I'm going to plug it into my calculator and get 21.561. Let me know if you have any questions about any of our new policies or anything like that. If you have anything about questions about parts, your next 2 days are just going to be focused on correcting the midterm exam. Since it's significantly longer than your previous exams, I'm going to give you 2 days where that's where I want you to devote your time and energy. It's also a great opportunity if you want to set up meetings with me or just even in emails and ask me questions about the midterm, about the corrections, or about this first set of lessons. Talk to you later.